Hi everyone, we're continuing with some Chapter 3 homework problems, number 8. A ladder is 9 meters long and leans against the side of a building. If the ladder is inclined at an angle of 75 degrees above the horizontal, how far is the base of the ladder from the building, and how far vertically up the side of the building does the ladder reach? Now this is stated a little more differently than some of the others, but it really is basically just a vector component problem. So here is my ladder leaning against the side of the building. It's 75 degrees above horizontal. So here's my horizontal, and it's 75 degrees above that horizontal. Here is the right triangle. I want to know the base of the ladder. I want to know this distance, x, and I want to know the vertical distance, y, and I know my entire ladder is 9 meters long. Well, that 9 meters, ladies and gents, that happens to be my hypotenuse. So let's do this one piece at a time. The angle here is 75, so x is my adjacent side. This is my hypotenuse, and the side not touching the angle at all, this is my opposite. In order to find x, x is going to be my adjacent, and in order to determine that, I'm going to use cosine. So the cosine of theta is the adjacent over the hypotenuse. So the adjacent, which is equal to x, is going to be the cosine of 75 degrees times my hypotenuse of 9 meters. And I pick my calculator up. If you are having a challenge making your calculator do what you want it to do, make sure you are in degree mode and not in radian mode or something else. That is often a challenge that students have. Okay, I end up with x of 2.33 meters. Now let's go ahead and find y. Y is that up and down component, so y is the opposite. I'm going to go ahead and use sine of theta is going to be the opposite over the hypotenuse, and so the opposite side, which is my y, is going to be equal to the sine of 75 degrees times the hypotenuse, which is my 9 meters. And if I do that, 75 times 75, the sine of it, times 9, and I end up with 8.69 meters is the distance up the wall. All right, that's number 8. Let's take a look at a projectile problem, number 9. A tennis ball is struck with a horizontal speed of 28 meters per second. It hits the court, a horizontal distance of 19 meters away. How far above the court was the ball struck? All right, we are now in the land of projectile problems. Now, when you do these, this is the way you handle projectile problems. First off, it's always handy to have a picture. So we have a little tennis player. The little tennis player is going to strike the ball with a racket, and the ball is going to go boom, like that. Now, we know that a horizontal distance 19.6 meters away, that is x, that is the distance it's going to travel, is 19.6 meters. We want to know how far above the court was the ball struck. So what we're looking for is y. That is our unknown right there. We have motion in 2 dimensions. If you have motion in 2 dimensions, what you have to do is you have to have 2 columns of data. So in my vertical direction, what do I know? Well, I know that it went a vertical displacement of 19.6 meters. I know that it had a horizontal velocity of 28 meters per second. And that's all I know in the vertical direction. I said vertical, didn't I? Mary made a mistake. That's horizontal. This is horizontal. Yes, I make boo-boos. I am very human. Okay, let's talk vertical. In the vertical direction, I don't know why. I don't know why. Now, if it goes in this direction, what is its original vertical velocity in this direction? It's 0. It's just as if it got dropped from this unknown height. So its original vertical velocity is 0, but we do know it's going to be accelerated downward by gravity. So we know the acceleration of gravity is a positive 9.8 meters per second squared. Why positive? Because all of the direction of motion is going to be down. We don't have up and down motion, which we'll have in further problems. So I'm going to call that positive. How long is it in the air? I don't know. I do not know the time. But here's one of the things I do know. I do know that when the ball hits the ground, it's going to stop moving horizontally and it's going to stop moving vertically. So whatever this time is, it's going to be the same for both the vertical and the horizontal motion. So here's what I'm going to do. On the horizontal side, we know horizontal velocity is constant because air resistance is minimal for things that are not moving supersonic and are relatively smooth. So horizontally, the equation we can use to describe that is going to be displacement divided by time. It's the only equation you get to use for horizontal motion. It's the only one. Don't try and use another one. And I have x, I have horizontal velocity. I can solve for time. Once I know time here, I can use the time there, and I can then go forth and find the vertical displacement y. So we're going to do a little magic algebra. I want to solve for time. I'm going to multiply both sides by t. T times horizontal velocity is going to equal x, and then I want to get t alone, so I'm going to divide both sides by vh. And I'm going to end up with time is x over vh. X is 19.6 meters. Horizontal velocity, 28 meters per second. Give myself a little bit more writing room right here. Pick up my calculator. And I have 19.6 divided by 28. And I'm going to end up with the time in the air of 0.700 seconds. That's as long as the ball's in the air. Now that I know this, I can use the time on the other side. Now the vertical information, if I analyze that set of variables, which equation has a displacement, VO, acceleration, and time? Well, the equation that comes to my mind is this one. X is VOT plus 1/2 AT squared, the drop equation. If the original velocity is 0, this whole part goes to 0. So I have x, which if we're talking vertical displacement can be equal to y, is 1/2 AT squared, and I know acceleration and time. So what is my vertical displacement? 1/2 the acceleration of gravity, 9.8 meters per second squared, time 0.7 seconds, quantity squared. Grab your calculator. Now we're going to put it in. 0.7 squared times 9.8 equals, divided by 2 equals, and I get 2.40 meters. Seconds squared, that's going to square the second units. That's going to cancel that second units. I'll end up with meters. That turns out to be meters. And that looks pretty darn good to me. So that should do it for that one. That's pretty tall. This guy must have definitely given it a good serve to get that started. All right, that'll do this time, and we'll see you with another projectile next.